Welcome. Let's dive into algebraic indices, your ultimate tool for simplifying those huge, scary mathematical expressions.
So how do we simplify equations without drowning in a literal sea of numbers?
We use indices. Like in 5 to the power of 3, 3 is our index.
You've got to master 3 fundamental laws of positive indices to absolutely crush your exam. Ready?
First up, multiplication. When multiplying terms with the exact same base, just add the indices together.
See, that means d cubed times d to the 4th simply becomes d to the 7th. Next is division. When dividing terms that share a base, you just subtract the indices. Easy. So m to the 4th divided by m squared leaves us with just m squared.
Finally, the powers law. If a power is raised to another power, just multiply those indices.
Check this out. 2p squared, all cubed, massively expands to 8p to the 6th.
But hey, what happens when we hit a weird edge case, like a zero index?
By matching subtraction against standard division, we actually prove anything to the 0 power is 1.
So c cubed times c to the 0 is literally just c cubed times 1.
All right, let's tackle another wild scenario. What do we do with negative indices?
Using our previous rules side by side, we see a negative index actually just creates a fraction.
Notice how that little negative sign flips the whole term right down into the denominator.
See here? Adding -2 and +3 just leaves us with g to the 1st power.
Okay, time for the final boss of this explainer. Can we actually have fractional indices?
Absolutely. A fractional index like 1/2 directly translates right into a square root.
The fraction's denominator tells you the root, while the top numerator stays as the power.
Applying this, a to the power of 3/4 becomes the 4th root of a, all cubed. Quick rapid-fire check. Multiplying p to the 1/2 and 1/3 gives us p to the 5/6.
So, how will you use these powerful index laws to solve massive unknowns on your next exam?